Okay, welcome to video 2. Once again, this is Justin, and I chose the Capstone 1, which is the Bad Bank application to prepare and present. We'll talk about on this video the database, which we chose to create a remote PSQL instance hosted on DigitalOcean. I think we'll describe that in more detail in the next video with regards to how we deploy everything. And we'll also, but in this video, the other item that we'll discuss are the API endpoints on the backend, written in the server code in our Express server. So to get started, let's talk about what data in the application is persistent and stored in our database. So I thought it'd be helpful just to show this form because this is the majority of the information that's persistently stored for each user that is created. So first name stored, last name stored, email and password are stored because, again, as we discussed in the first video, the email and password need to get authenticated to log in once an account is created, and they get authenticated with queries run against the database to check that the email in fact does exist, and if that email exists, the password that you entered matches the email in that row of the database. So anyway, back to what data is persistent. Again, these 1, 2, 3, 4, 5 fields. This one is optional, additional information. The others are required. So let's do an example for you. Let's do what's something clever? Let's do Zeus, last name Olympus, email, let's do zo at greekgod.com, password, let's do immortal, and additional information, let's just say showcasing persistent information in the database. All right, so this should pass all our checks, which it does. So that component is unmounted and this modal is mounted, which means that we can now view the account balance for the new user that we just created. So let's view the account balance. Obviously, it's a new user. So again, this is something that is created as a column in the database once the creation of the user happens in the database. So this is I think the last probably persistent piece of information in the database as well. And obviously it's initialized, the value in this row is initialized at 0 when you create a user via the endpoint, I think we call it the create account endpoint. All that logic happens there. So just to show you what our database looks like, so here, this is a shell. So I established a connection to the database, to the remote PSQL instance from my command terminal, which is kind of acting as the client, which is my pseudo backend, where I can send requests to the database and get responses. So these are our previous users. You can see we've an ID column as well, which we use the serial component in the schema combined with the primary key component. So this auto generates, auto increments, but I think we talk about that more. I'll probably talk about that more in additional features in the third video. But I guess I could talk about it here too. I don't know. We'll see. We'll see how long this video is, and then we'll make that call. Okay, so now so we just created that new user. Obviously you don't see Zeus in here, but let's rerun that query and get our response. So now you see Zeus is the 6th, which is due to our auto incrementing component build for the value that goes into the ID in the schema. You can see first name, last name, email, password. This is again optional, but it's included. This we have a column called other for. Then the balance gets initialized at 0 in the database, always for a new user. And we also actually included another column, which again runs in the server code in the API endpoint to see when that user was created. That just be need to keep track of. So now we can see, we can test, or I'll just quickly showcase how our account balance is stored persistently in the database. So we do deposit. Let's deposit $100 for Zeus, complete transaction. Great. So now we see our account balance is updated here. And let's send another request to the database. And we get a response. You can see here Zeus 100, right? And then, let's log out and just log back in. Oh, geez, let me remember the username. Zio and Immortal. Greek. Immortal. So we can see it's persistent, right? Our account balance stays at 100. Perfect. Okay, so I think that's... Oh, let's talk about this too quickly. So let's go to our directory. So this was a feature that I built also, where instead of establishing a new connection to the database, or having to establish a new connection to the database every single time a query is sent, i.e. a request is sent from the backend to the remote PSQL instance, we leveraged this pool class from the PG library, which once instantiated, once a new instance of this pool class is instantiated, opens a connection, establishes a connection to the database based on the configuration here, and also, it establishes a configured connection to the PSQL instance, the remote PSQL instance, and then you can specify which database to open the connect to connect to within that remote PSQL instance. The best part about this pool class and using this part of the library is that it establishes, instead of just one connection, which is then closed once the query resolves the request to the database, i.e. the request from the backend server to the database once the request to the database server receives a response, the request from our Express server at our API endpoint, instead of closing that established connection and then having to reestablish a new connection the next time a query is sent, this pool class basically establishes a pool of connections, which are then held by this database variable. Again, they're configured based on what you pass in as your configuration object. And those connections, once the query to the database resolves, actually continue to stay established and kind of like get recycled into this pool. So say this opens a pool of 10 connections. Those connections won't get closed until this entire process ends. So said another way, each query that happens, each query here, actually, let's just go here. So as you can see, here's a sample API. The query method from the PG library also operates on this database variable, which holds the pool of connections. So what happens is there's software written into this query method that requests one of the established and configured connections from the pool, which is held by the database variable because, oops, that's not it, because the database variable, points to this newly instantiated pool class. Receives one of those established connections and then sends a request to the database specified in the configuration of the established connections with a SQL statement to execute against the database, and the database then receives that request, executes the request, and sends a response back to the server. But instead of closing that connection permanently, and then the next time we, let's do and then say we immediately do another transaction, right? Like this is another API. Say then we do, or sorry, this is the other API, and this is a database query within it. So say then we immediately do another transaction like here, right? So we want 200 complete transaction. Instead of having to do that whole process all over again, where you need to reestablish the connection, right? Everything happens, and then you unestablish the connection, which takes up a lot of resources and a lot of compute. This pool of connections stays active, which means that, and if say all 10 connections were in use, basically this query method will wait until one of the other queries that is running from some computer, requested by some computer elsewhere, is finished, and then an established connection gets returned back to the pool, and then it'll be get given to this query method. So it's a great way to set up this whole piece of the application, of the architecture of the application, so that you don't need to continuously, every single time you send a new request to the database, reestablish the connection with the database over and over and over again, basically for every time you hit an API endpoint, and that includes a query to the database within the logic. And again, the significance of that is that establishing that connection to the database uses a lot of resources and a lot of compute. So it's way more efficient in your application. All right, so I think that's pretty much everything on the database side. In the interest of time, let's move over to the API side, since we're kind of talking about this already. So we use RESTful APIs, as you can see here. Let's describe each endpoint and the role. So I think we have 3 endpoints here. So we have, this one's unused. So we have our add endpoint. So this endpoint receives requests from, let's log out, from the front end HTTP API request that is triggered by submitting this form. Those requests are received by this add endpoint. We have a login endpoint. The login endpoint receives front-end HTTP request triggered by the submit button on the login component, the login form. And then we also have which we already kind of went over, so in the interest of time, I won't show you again on the actual app. We have the transaction endpoint, and the transaction endpoint receives API requests, front-end HTTP API requests triggered by submitting, submitting a transaction in that account balance component that we were on earlier, which has deposit and withdrawal and the amount.